Good morning, Pirates. Today's video is for Tuesday, April the 28th, 2020, and today is International Astronomy Day. I saw a news article where on, I believe it's May the 16th, Jupiter, Venus, and the Moon will come together to create a smiley face. So that'll be an interesting event. Double check the time and the date, but it looks like a lot of fun. Today's lesson is over thermochemistry and nuclear chemistry. So those are a couple of big words. What do they mean? Thermochemistry, the branch of chemistry concerned with the quantities of heat evolved or absorbed during chemical reactions. So either heat being let out or heat being absorbed. Nuclear chemistry is the branch of chemistry concerned with nuclear reactions. Let's elaborate on thermochemistry a little bit. An exothermic reaction is a reaction that releases heat energy, something like hand warmers. It lets out heat. Endothermic is a reaction that absorbs energy, like melting ice, or like we did in class, the baking soda and the vinegar always made the beaker cold because it was an endothermic reaction. If you look at our diagrams here, the exothermic reaction, and you can see it's letting heat out. Endothermic is cooler than the surroundings because it is absorbing the energy. Nuclear chemistry. We are going to discuss the three main types of radiation. We did discuss these earlier in the year, but we're going to go into a little more detail. Alpha radiation, the nucleus of an atom becomes unstable. The ratio of neutrons to protons is low, and alpha particles, which are also a helium nuclei, are emitted to restore balance. It can be used to treat cancer. Beta radiation is a stream of electrons emitted at a velocity approaching the speed of light. This is used in medical imaging. Gamma radiation has the smallest wavelengths and the most energy of any wave. Remember how energy and wavelength have that inverse relationship? Tiny wavelength is lots of energy. They are produced by the hottest and most energetic objects in the universe, such as neutron stars and pulsars, supernova explosions, and regions around black holes. On Earth, gamma waves are generated by nuclear explosions and lightning. Here's a diagram that kind of shows the alpha radiation kind of stops when it hits the body. Beta radiation is able to pass through the body. And gamma is able to go through the body and the aluminum, but it's stopped by lead. There are two types of nuclear chemistry. Fission is the process in which a large nucleus splits into two smaller nuclei. In this case, energy is gained. An example is uranium splitting into smaller atoms, such as iodine, cesium, strontium, xenon, and barium. Fusion, it's what it sounds like. It's something being fused together. It's the process in which two atomic nuclei are fused together into a larger single nucleus. In this case, energy is released. This is what's happening in the sun. It's fusion, and the energy being released is the sunlight that we see. So an example would be four hydrogens coming together to form helium. We have a discussion question in our digital notebook today. It says, what type of radiation created the Hulk? How exactly did this happen? And could it happen in real life? Support your answer with cited sources. If you want to be a little extra, you can create a video of your findings.